Hey guys, campus is closed, so we're gonna give you the kind of fast and dirty version of the lecture I gave this morning to the other Algebra 2 class. So homework questions will have to wait, but today we're going to talk about section 8.2, which is roughly lines. Okay, so first and foremost, for lines, we're going to need to remember some stuff. So we need to recall from earlier in this class the idea of a function. Okay, so since there's nobody here, this is going to be a bit boring on feedback. Maybe I'll make some up. So does anybody remember the definition of a function? Oh yes, that's, oh, I can't play that game. All right, so a function, right, is a rule or association, right, between inputs and outputs. I'm not sure actually how well you'll be able to read this. I'll make sure to use a dark marker. So if it's an association between inputs and outputs where each input maybe is associated with one and only one output. Right? I'm hoping you guys remember this. So pictorially, this is this thing, right? We've got a blob over here, some rule, and a blob over there. This blob we call the inputs. This is also known as the domain, right? Usually we think about those as being x's. Usually we call this rule f, so let's just do that. Then over here there's this other thing. This is the outputs. You guys remember the name of this thing? This is the range. Okay, and what do we call things in there? I think we usually call those f of x's, right? So f is this rule that takes x and puts it to the output f of x. Cool with this? All right. There's another definition we need to recall, which is the graph of a function. Right? Is the set of ordered pairs x comma f of x, right? Where f is the rule. Suppose graph of a function f, right? And by ordered pairs, really we can think, instead of ordered pairs, we might think points. Right? Okay.
Campus is closing.
Thanks.
Okay.
Okay, so campus is closed, by the way, in case you hadn't figured that one out. All right, there's our definitions for function and graph. Now, there's this other thing that we need to recall, which is from a different class. So this stuff I'm hoping you remember from earlier in this class. Now, from someplace in your mind, maybe Algebra 1, high school, something. I'm hoping we recall something about lines. All right, so this is the point where having people here would usually help. So usually somebody pipes in that 2 points make a line. Okay? Let's see, then usually somebody pipes in with the idea that a line is a y equals mx plus b. Let's see, what else do we get? Usually we get something about slope. Okay, so I want you to look at this for a second and think, okay, what's the slope here? Well, the slope here is the m. And slope for a line, I'm hoping you all recall, is rise over run, which we think of sometimes as delta y over delta x. Don't sweat the little delta symbol too much. All it means is change in. Okay, so we've got our m, that's our rise over run, which is our change in y over change in x. Let's see, what else do we need to know? What about the b? What's the b? That's the something intercept. Maybe the y-intercept? Alright, so pictorially what we mean is here's 2 points, maybe these 2 points, here's some axes. My line that goes between those looks something like a different color. My line that goes between those looks something like this, right? Not my best line ever. And then on this picture, let's see, I should be able to label the slope and the y-intercept. So let's see, what do I mean by rise? By rise, I mean this kind of vertical difference, right, between these 2 points. So that distance is the rise. The run is the sort of horizontal distance between the 2 points. Some of you probably think about these the other way, which is fine. So this is also the rise over here, and the run is this distance here. Okay? So there's our slope. Where's the B on the picture? The B on the picture, and maybe yet another color, is this distance here. So why do we call that the y-intercept? That's because we hit this axis, y. Hi.
We closed campus.
I know.
Gonna have to leave.
Okay. Can I record a lecture for my students so they don't stay? Okay. Can I have 2 minutes to finish my thought? Thanks.
Go ahead.
Are you going to stand there while I do this?
Yeah.
Okay. All right. So, I guess we're finished with lines. Thanks, guys. Hey guys, so the Gestapo kicked me off campus so that I couldn't finish the talk earlier. So, welcome to my garage instead. Yeah, I know, it looks a lot like a classroom though, but it's got chalkboards, so it's better. So let's see, we needed to finish talking about lines. And we got through most of the stuff I wanted, but I want some examples for you guys. I also want to kind of iterate the difference between what we were thinking before and what we're thinking now. So before, in say Algebra 1 or something, we were thinking y was mx plus b, right? We're remembering from the other video that m is the slope and b is the intercept, right? So in this class, what we're going to do is we're going to sort of step our thinking a little bit to the side, and we're going to think about this thing as a function, right? So as a function, what I mean is really, we're going to say, okay, here's a rule. F of x is mx plus b. So for a given value of x, right, f is a function that transforms that into a, well, what we used to think of as a y, what we're now thinking of as an output, right? So, sorry, my phone battery's dying. So what we want to do is we want to think about this and its relationship to this other thing that we think of as a line, right? Which is maybe something like this, right? We think of this guy as a line, and we think of this guy also as a line. So in what way are these the same thing? kind of wondering, I call them both a line, but what do I mean by this? I hope you guys are noticing that this is probably the graph of that rule, right? So here we have a function rule written out, and here we have a graph of a function. So remembering the definition of a graph, these are points. They're points x, comma, f of x pairs, assuming that here we're drawing the graph of the function f. Pretty cool, that? I'm going to assume you are, since you can't talk back. All right. So we need a couple examples. I would offer you the choice normally as to whether you wanted to learn the real world example first or the kind of dumb example. I'm going to give you this sort of real world thing, and then we're going to do a slightly easier thing after that. So the real world thing is this thing called linear regression. And this linear regression is sort of a stats topic. It comes up actually in a lot of places. This is probably the #1 thing that lines get used for in real life. It's also probably the #1 thing that stats gets used for in real life. So this is kind of a big deal. The idea here is actually not super hard. The idea is I have something like some data, which might look like this. So I have some data points, and we should probably give this some meaning. So maybe my most recent example for this was buying a house. So say this way, I've got square footage, which my realtor told me was maybe the most important variable for buying a house. So I have square footage, and then this way I have sale price. Okay, and here are some homes that sold, right? So each point on this will be something like a square footage. Like say this one's a fairly big house, that one might be 2,500 square feet. And it has a sale price, and the sale price might be, oh, I don't know, $300,000. So 300K here. That comma is confusing, so I'm going to drop it. So we've got one of our points on our graph. This one is 2,500, comma, the sale price, which was $300,000. Okay, and now these are homes that have sold, right? These are data that I've collected. And I'm maybe interested in something like this. My square footage on the house I want to buy is like here. So I'd like to know maybe some kind of what should a fair offer look like, right? So the way we do this is we cram it into some kind of fancy formula like Excel. And actually people are really good at this. So I hope that you guys can see that there's kind of an upward trend to this data. So most of you are probably pretty good at noticing that really a line through that would look about like this, right? Maybe we'll make that end a bit longer. So if we want to find out what a fair offer price for this square footage would be, we'd follow this square footage up to our line, and then we'd follow it over to the sale price that corresponds. So this is maybe what our fair offer would be. I haven't put any axes on here, so that's a little bit hard to follow. Another way to look at this would be to say get a formula. So out of Excel, maybe I get a formula. So I get like P, right? Sale price is, and I think the one I got for when I was shopping around here was 145F plus 68,000. Okay, so this is a function, right? P is a rule. It takes something and turns it into something else. It takes square footage, right? Footage over here, P, and then turns it into, well, P of F, right? Really, if I was maybe suppressing my notation a little bit less, I would write this. So it takes a footage and it turns it into a P of F, which is a sale price. Or at least an estimated sale price. Okay, so what does the slope mean here? And what does the intercept mean? These are things we can actually interpret, right? This is my intercept. This is the value of a 0 square foot house. That seems stupid, right? Yeah, kind of stupid. but has a good interpretation. What's buying a 0 square foot house? Well, really, I don't think 0 square foot house. Instead, I think the lot that the house is on, right? That actually makes sense. And it turns out $68,000 is about a reasonable price for a lot. So I think I'm good with that. Now, what's this number? This is the slope, right? Which we think of as a rise over a run, yeah? So what's a run in this case? A run is a one unit increase in the input. That's a square foot. So this 145, that represents $145 per square foot. Does that make sense? I sort of hope it does. Nobody can ask me anything now because of this silly video format, but I hope that follows. Okay, maybe we do another different example. So let's do a kind of a dumber, more mathy example that has less kind of weird variables in it. So the other thing we might want to do with lines is like say put a line through a couple of points. And this will help you do your homework. So let's do that. Let's do, for example, find an equation for a line through, I suppose, instead of between it. Through is better language. Through 1, 2, and 3, 5. Okay, so how do I do this? Well, there's sort of two approaches. I'm going to start with the graphical kind of idea because I think that's a bit more intuitive, and I think that's going to be especially useful since you can't kind of ask me questions in this format. So let's try the graphical idea. So here's some axes, right? Put some ticks on the axes maybe. Okay, so let's see. I want to graph the point 1, 2. So how do I do that? I should go over 1 unit, right? And then up 2. So here's the point 1, 2. Okay, now I should graph the point 3, 5. So I go over 3 units, up 5 units. So I get my point 3, 5 here. Now, I should be able to draw a line between those. Okay, so I do that. There's a line between those. This is my, I don't know, I haven't named anything yet. Maybe if we call this the x-axis and the y-axis, that'd help. Maybe I'd call this F, right? Okay, what do I know about F? Well, a lot of you probably observed that this line kind of goes up from left to right. That means that there's a positive slope, right? So my slope is positive. Well, I can do a bit better than that, right? Can I calculate the slope? Should be the what over the who? Maybe the rise over the run. So if I draw this little triangle in here, how long is this side? Well, conveniently for my picture, I can just count that off, right? It's 1, 2, 3 units long. How far is my run? Well, my run is 1, 2 units. So what's my positive slope? In fact, it's not just positive, it's 3 halves, right? So I found m, right? M is 3 halves. That's part of the way to finding an equation, right? Now, this other bit's harder, especially using the graphical idea. I would like to eyeball how far up the intercept is, right? So I would maybe guess something like B is approximately a half, but I would like to do a bit better than that, right? So to do a bit better than that, I'll use my information that I found about M and my idea that this ought to be a line. So lines look like y, or f of x maybe, right, is mx plus p. Okay, what do I know about mx plus p? Well, I know I can take the m out, replace it with 3 halves. Right? Okay. What do I know about x and f of x? Well, those should be things on a graph, right? So I need to find something on the graph. Oh, very conveniently, I have things on the graph. So you can use either one of these. It doesn't matter which. Let's use this one. So if we plug that in, which one's the x? So I need whatever the x is here, plus b, and whatever the y or f of x is there. So the f of x is the y coordinate, right? The second coordinate, so that goes here. This gets the 1, the first coordinate. So again, I'm using this point. And I'm kind of thinking about this point. I'm thinking, okay, this is the x value, and this is the y or the f of x value for this one. Okay, see that? Okay, so now how do I solve for b? What should I do? Well, this is 3 halves, right? I want to isolate b, so I should move that to the other side. So I get b is 2 minus 3 halves. And then I think, okay, 2 is 4 halves. Right, that's multiplying top and bottom. Really, this is 2 over 1. I'm multiplying top and bottom by 2, so I'm not changing anything in that. So I know that 2 is 4 halves. Minus 3 halves is 1 half left over. So my line's equation is y, or f of x, equals 3 halves x plus a half. Cool? So we found this. That's our equation. Keep in mind that's an equation. There are going to be a bunch of equations that are going to look pretty similar later when we start doing more of these. But this is an equation. Cool? And we could check our equation by plugging in the other point, right? If we plug in 5, we ask, okay, is 5 equal to 3 halves times 3? Wait, 5, yeah, the y, right, equals maybe 3 halves times 3. Oh, I need to add my halves though, right? Okay, so I'm wondering, are these equal? Well, this one is equal to 9 halves plus a half. Okay, that's 10 halves. So are these equal? I think yes, they are. So check, right? This goes through both points. It goes through 1, 2 because I forced it with this. And it goes through 3, 5 because I just checked that. Cool? All right. This is what I wanted for 8.2, so please get started on the 8.2 homework. Thanks, guys. Sorry that class was weird today. Bye.